Hello everyone, it is a pleasure to be here today to talk about a foundational yet incredibly versatile concept in mathematics, sets, that form the building blocks of modern mathematics and have applications in countless fields, from logic and computer science to real-world problem solving. And that's my contents and the operations on sets is the key points. And the first section is introduction. George Coulter, in 1874, Coulter first introduces the concept of sets and studies the properties of infinite sets that emerged in his work on real numbers. And the next section is basic concepts. Set representations that are typically denoted by uppercase letters, such as A, B, C, and about membership. If an object X is an element of a set A, we write X belongs to A. And the next is type of size. First is finite set, a set with a countable number of elements. And two is infinite set, a set with an uncountable or infinitely many elements, and three is empty set, a set with no elements denoted by like this, and the next is a universal set, the set that contains all elements under considerations in a particular context, often denoted by U, and five is subset, a set A is a subset of set B if every element of A is also an element of B. The final is proper subset. A subset A of B is a proper subset of B if A does not equal B. And the next section is the key point is operations on sets. And the first is union. The union of two sets A and B is the set containing all the elements that are both A and B. It is denoted as A union B. For example, if A contains 1, 2, and B contains 3, 4, then A union B contains 1, 2, 3, 4. And next is intersection. The intersection of two sets A and B is the set containing all the elements that are common to both A and B. It is denoted as A intersection B. For example, if A contains 1, 2, 3, 4, and B contains 3, 4, 5, 6, then A intersection B contains 3, 4. And next is difference. Difference of two sets A and B is the set of elements that are in A but not in B. It is denoted as like this. For example, if A contains 1, 2, 3, 4, 5, and B contains 4, 5, 6, 7, then the difference of A and B contains 1, 2, 3. And finally, the complement. The complement of set A is the set of elements in the universal set U, but not in A. The complement of A is denoted like this. For example, if U contains 1, 2, 3, 4, 5, 6, and A contains 3, 5, 6, then the complement of A contains 1, 2, 4. And the next section is Venn diagrams. A Venn diagram is a usual representation of sets. The universal set U is typically represented by a rectangle, while the subsets of U are represented by circles or other shapes such as triangles. And the next section is properties of sets. In mathematics, sets have various fundamental properties that help us understand their structure and the relationship between them. These properties make set theory a versatile tool for problem solving in mathematics and applications. And then the final is application. And the first is mathematics. Sets are used to define sequence and functions and vector space and are widely applied in branch such as number theory, geometry, or probability. And next is computer science. The concept of sets is applied in data structures and it's also in the database queries and algorithm analysis. And the next is logic, such from the foundation for describing logic propositions, and it's also in our everyday life. Sets can be used to classify and manage data, such as student lists, categories of products. Thank you very much.